Hello everyone. A very good afternoon to all of you. I am Priyanshi, welcoming you all on behalf of Solar Quarter and First View Group to our webinar on how the latest PV technology can boost Philippines solar development. Thank you all the attendees for joining us today. I hope all the attendees had a great time in networking with your peers in our exhibition tables. If you haven't visited yet, no worries, the platform will be open till 6 p.m. today, so you can start networking at that time. As you all know, we had a contest associated with this webinar. So the winners will be announced at the end of the webinar. So before starting today's proceeding, I take the opportunity to thank and welcome our partner for this event, that is Trina Solar. Now I request my team to start with the sponsor video of Trina Solar. Thank you so much for playing the video. Now, without any further ado, I would like to invite Mr. Xiong Bun Lim, who is from Trina Sola, for the sponsor presentation. The screen is all yours, sir.
Yeah, thank you. So let me share my screen. Okay, I hope everyone can see my screen now.
Yes, sir. Please proceed.
Okay, thank you. So thanks again to Solar Quarter for organizing the event today, and thank you to all the participants for coming in. I'm Lim from Trina Solar, so I'd like to take this chance to give a brief introduction about Trina Solar and also our latest product that is suitable for the PV projects in Philippines. So just a brief introduction about Trina. So we are founded in 1997 and we have more than 20 years of experience in PV module manufacturing. So along the way, we become the world's largest PV module supplier in 2014. And then in last year, one of the key milestones is that we have relisted ourselves onto the Shanghai Star Market and also launched the PV modules into a new era of more than 600 watt power beam modules. So in terms of globalization, we have a widespread offices all over the world. So myself is based in Singapore, which is also the Asia Pacific HQ for Trina. So from here, we are supporting the ASEAN region plus Australia, India, and also some of the other countries like South Korea. So cumulative, we have shipped more than 70 gigawatt since the company is formed, and we have about 15,000 employees worldwide. So in terms of bankability, we are happy to say that we have been ranked 6 times in a row by Bloomberg New Energy Finance as the top most bankable module supplier for the past 6 years. So in terms of our footprint in Asia Pacific, over the last 3 years, we have shipped almost 9 gigawatt of module shipment in the Asia Pacific region. Then from our leading technology, since early last year, we have launched our 210 solar module. So this is also has also propelled the solar industry into the 600 watt era. So at the same time, now we have also starting our N-type iTopCon. So with average efficiency of up to 24%. And we are also actively researching on HJT technology, which might be coming sometime next year. So just a brief look back again on how the module power bin has evolved over the last 10 years. So we can see that it has been especially exciting over the last 2 years where we see module power bin breaking through 500 and then 600, and now we are offering the biggest about 670 watt. So we also foreseen that probably the 700 watt era will come very soon. So this has been once again shown in the June exhibition this year, one of the largest PV solar exhibition in the world in China. So we see that a lot of suppliers have also adopted the 210 cell size and offering power bin between 600 to 700 watt. So when we first started the 600 watt era, there was only about 30 plus partners that have joined this alliance. Then we fast forward now about 1+ years onwards. Now we have more than almost 90 companies that is inside this 600 watt ecological alliance. So in terms from all the way the downstream to the BOS, to the modules, inverters, and also the certification organization. So this show that the 600 watt era is definitely here and will be the way forward. So this is our Trina comprehensive 210 Vertex family. So you can see here we offer actually 5 series of products. Starting from the left is our product that is used for the residential market. It's a small footprint up to about 400 watt, 405 watt. And then in the middle, we have the 1819 series, which is we are using for some of the commercial and industrial rooftop projects, and 2021 series more for the ground-mounted projects. But of course, depending on the projects and the application, most of the series also can be applied to whatever projects that is required. In terms of technology-wise, these are the 4 key technologies that we are using inside our modules. So from the top left corner, this is the largest size wafer available now, the 210. And then to match with this, we have also increased our number of bus bar. So we are using 12 bus bar for our Vertex series. And since the surface area of the cell has become bigger, we have also upgraded our cutting technology. So we are using a non-disrupting cutting method so that we can get a similar mechanical strength as compared to a non-cut full cell. Then at the same time, we have also adopted the high-density interconnection technology. This is basically to minimize the cell space between the gap between each cell so that we can improve the module efficiency. So these are just a bit more details on our 210 Vertex series. So it's actually available in both the bifacial dual glass and also the monofacial backsheet version. So this is our highest power bin module now, 670 watt. So you can see it incorporates all the technology that was mentioned earlier and is based on a low voltage, high current design. So from there, when we put it into the system level, you can see that as compared to the others, we are actually getting about more than 32% more string power as compared to other competitors. So we have also done extensive study with third-party agency like Fraunhofer. So this is 2 case study that was done, one in Germany, fixed tube, and then in Spain, it's a bifacial one portrait tracker. So we can see from the study and the simulation done, the G12 here is referring to our 210. The power bin used here is 665. So as compared to the others, like the 182 family using 540, 545, we do see savings coming in terms of the Capex. And at the same time, that we also can get savings at the LCOE level. So these are just a bit of more details. First, we can look at the project in Germany. So as compared the savings in terms of the capex. So basically, the savings is coming from the PV modules because the quantity, the number of modules used are less. So also in terms of the engineering work, the electrical system, the mounting and installation will also give us some cost savings. So finally, when we put all these cost savings into the system level, it will translate to about approximately 4% reduction in the LCOE. So this is for the fixed tilt study. At the same time, we also have do another study in Spain, which is the one portrait tracker. So similarly, we can also see when we use Vertex high power beam modules, we can get savings from the tracker part and also on the mounting and installation. So this is the breakdown where we can see the specific numbers and the assumptions that we have made in this particular study. So overall, the summary shows that we will get savings in the mounting installation, electrical system, and also some of the freight costs. And this mainly comes from 2 points, which is a high power bin of Trina modules and also the low voltage high current design, where we increase the string power. So total, this will translate to less number of modules used in the project, and this reduce labor cost and installation time. So in terms of Trina reliability assurance, so I think no, for the 600 watt and above module 210 is not exactly new, but it is still taking some time for the our customers to understand more. So we do have a lot of questions on in terms of how stable is this module and a lot of others. So we look at it in terms of the module variety in the three different aspects. So you can see definitely in terms of production wise, everything is following Trina's strict product control, product quality assurance system. And also we have our own state key laboratory that's doing all the product design and verification. Then when we put it into the actual system, will be when we look at the mechanical reliability, the delivery solution, and the electric reliability. So in terms of the product optimization design, so over here we have done extensive research and study, and then we can see when we compare our Vertex 670 watt module to the others, it's about 4.6% longer in length compared to the 182, but it's actually still about 3.4% shorter when we use the 78 cell footprint for 182, and it's about 15% wider. So despite the module having a slightly larger surface area in terms of dimension, we have also improved our frame design. So the frame design itself has been optimized, the frame chamber and some of the other details, so that we are able to maintain the same mechanical loading properties as required and also compared to the traditional module. So to show that we have done another 5 enhanced tests, namely the non-uniform snow load test, the static loading under extreme low temperature, hill impact, enhanced dynamic load, and also the wind tunnel test. So when we have a highly reliable product, so this will ensure that the solar project is able to generate power over the whole lifespan of the system. And all these tests has been conducted by independent third parties, and test samples are randomly picked from our mass production. So first we can look at the standard static load test. So basically we are able to achieve the 5,400 Pascal front and 2,400 Pascal back. And also similarly for the tracker is 2,400 front and 2,400 back. So this put it at the same level as compared to the conventional modules that we have seen in the market. So on the non-uniform snow load test, so this is basically to simulate the snow load they might gather on the lower half of the module as shown in the picture here. So overall, when we do the 2.8 meter of snow load, which is equivalent to about 7,000 Pascal, the module itself is not damaged, and when we do the post testing, the power derivation is only less than 0.56%. So next, this will be the static load test under extreme temperature. So this might not be so applicable for the Philippine market, but in some of the other countries like in Europe, Japan, this is a concern where they have very heavy snow, extreme cold winter time. So we have also done the tests under this kind of extreme low temperature, and there's no significant damage to the module, even at such low temperature. Then this is the hill test that we have done. We have used the 35 mm. Let me see if I can play a video here. You can just see the kind of impact that is hit onto the glass itself. So there's no damage done to the glass, and we are able to pass the 35 mm test. So this is the enhanced dynamic load test. So basically it's a plus minus 1000 Pascal front and back. And we have put the module through about 20,000 cycles to test the robustness of the module. So you can see here for Trina Vertex module, the 670 watt, we have used two different installation methods, but both of them have managed to withstand the test itself. And after the test, the power degradation is less than it's about 0.1%. Then we have also tried out in the wind tunnel test, where we increased the wind speed from 30 meter per second all the way to 62 meter per second with a duration of about 30 seconds. So you can see here, basically, the modules are still intact, even at a higher wind speed. But of course, I mean, beyond that, the module might have some damage. So you can see the EL pictures on the right, before and after. And this is based on our installation method of using the screw and also the hybrid, which will be the screw plus the clamps. So another common question that we always get is, how are we able to transport these large footprint modules? So if you can see here, on the left is our standard horizontal two-stack packing. So on the right will be our new innovative packing, which is suitable for the large modules, which is a vertical placement. So this is how it will look like inside a 40-foot container. And if you can see, even when we compare to the others, although our number of pallets are less, but actually because of our high power bin, the total power per container is actually increased as compared to the others. So these are some of the projects that we have delivered, and this is some of the pictures that I'd like to share with everyone, how we are managing it on site and how you can also manage large modules on your particular project size. So this is a 112 megawatt China project in Qinghai. So it's using our 660 watt bifacial module. So on the right side picture here, you can see this is our stand supporter, which we're able to secure the modules properly at the installation site. So this is also another example which we have delivered in Japan itself. So in terms of using the forklift at the project site, unpacking the modules and bringing it to the actual structures for installation, these have also been verified. Last one will be one of the project in Korea. So this is a small 1 megawatt project which is used on a fixed tip. So in terms of compatibility wise, we have worked with about 21 mainstream inverter suppliers, and there's more than 200 models of inverters that's already compatible with Trina low voltage, high current, high power modules. So these are also some of the case studies that we have done. And besides the inverter, then of course, for some of the large ground-mounted projects, there's also use of trackers. So we have also worked with the 14 top tracker suppliers in the world, and they all have compatible design with our Vertex module. So we have also launched a Trina design tool. So this is a website which is we use it to help our customers in terms of some of the selection for the inverters and to check the compatibility. Yeah, so these are all the inverter company that is compatible with us. And lastly, this is our current global application case study of our Vertex high power modules. So we have started to supply all over the world, almost about 10 gigawatt. So you can see here, or maybe on the bottom half of the table, some of the projects that is already installed in the ASEAN region. And we are also sign about 25 gigawatt of Vertex orders. Okay, with that, I will end my presentation. Thank you everyone for the time, and back to the host. Thank you.
Thank you so much, sir, for your presentation. And now requesting my team to play the sponsor video of Trina Vertex series. Thank you so much, team, for playing this video. So now it's time to begin with our much awaited panel discussion, which is on how the latest PV technology can boost Philippines solar development. And to discuss this, we have in our elite panel Mr. James Baskowitz from Baskowitz Group, and he is also the session chair for today. Ms. Maria May Milante, who is from MRC Allied, Mr. Evan Woolard from DNV, Mr. Lim from China Solar, and Mr. Seen Oka from Citigor Power. So the discussion is led by James Sir. Now I'm handing over it to you, and also request all the attendees to put their questions in the Q&A, which will be answered by the speakers at the end. Thank you.
Thank you very much, Priyanshi. Good afternoon, everyone. In the last few years, the Philippines' solar development has rather been slow compared to its Southeast Asian counterparts. And this is largely due to the inefficient regulatory framework. But today, I have the honor to moderate a very exciting panel consisting of large developers, investors, panel manufacturers, contractors, technical experts, and consultants to talk about how the latest PV technology can boost Philippine solar development. My name is James Buskowitz, CEO of Buskowitz Energy, and I'm excited to kick off today's discussion. But before we start with the questions, can I request each panelist to give us a quick 30-second background and introduction of themselves? And maybe we start with the ladies. So, May?
Thank you, James. Good afternoon to everyone. Thank you for logging in for this very special afternoon insightful discussion with Solar Quarter webinar. Thank you for having me. It's my first time to be in this event. My name is May Militante. I'm representing MRC Allied Incorporated. We are a publicly listed company, and one of our portfolios is renewable energy. So we currently have a 50 megawatt operating plant, solar as it is, and we also have ventured into solar rooftop projects and hoping that we can continue on with the rest of our project as we pick up from the pandemic and we build more projects in the future. Thank you. And to the rest of the panelists, nice to meet you guys. And yeah, I'm looking forward to an insightful discussion. Good afternoon, everyone.
Thank you very much, May. And maybe, I mean, Lim, we heard from you earlier, but maybe it would be great to just have a quick introduction as well.
Yeah, sure. Thanks, James. So I'm Lim from Trina Solar. So basically, I'm the product and marketing for Asia Pacific region. I've been with Trina for almost about 10 years. So I'm working closely with our customers in the APAC region on the product issues and also handling some of the new product promotion and training for our customers. So nice to meet everyone. Thanks.
Thank you very much, Lim. Next, we'll have Evan from DNV.
Thanks, James. My name's Evan. I'm the head of section for solar within our renewables advisory department. I'm based here in Singapore. DNV is a technical advisory firm headquartered in Norway with more than 150 years of heritage, and we have more than 400 technical consultants for our energy systems group in Asia Pacific. Thank you for having me, James.
Thank you very much, Evans. Great to have you here. And finally, engineer Sean.
Hi, good afternoon, James, and good afternoon to everyone. Thank you very much for taking me here and this significant event. I am Sean Oka. I am from Citicore Power. Then I am an operation and maintenance head. Citicore Power had been developing solar in the Philippines, starting from the northern to the southern, or what we call the Luzon, Visayas, and Mindanao. We have 8 significant solar sites and around 170 plus megawatt peak capacity, and we are still looking into another 1 gigawatt capacity in the next 5 years in the making. And our main objective is to set footprints here in the Philippines for the renewable energy, especially the solar aspect of the renewable. And we are also looking into other ways such as hydro and other forms of renewable energy. Thank you and good afternoon.
Thank you very much, Sean. All right, so I think probably one of the most important questions today will be first to get an overview of the PV market, the solar PV market in the Philippines in general today. So, I mean, in 2021, we're still in the pandemic, but we've just overcome 2020, which was a difficult year for many, and that followed from, I think, a lot of very exciting years of growth in this market. But it would be great to hear. We will have obviously different opinions from local developers, investors, international. So to kind of understand how everyone views the Philippine solar market today, maybe we can start with May again.
Okay, well, maybe let me take you back pre-pandemic. We were all optimistic since being a developer. There's been like a very promising growth in terms of solar energy development in the Philippines. However, we got disrupted with the pandemic. But generally, the solar energy market in the Philippines is practically expected to grow, although we are in a nascent stage, as we call it. But with the current policy changes, the increasing government support, I think, or we feel, and we are optimistic that the solar energy market will be a very promising niche, a very promising investment for us being developers, because it does not only pose an opportunity in the utility scale aspect, but it has also posed an opportunity even in off-grid areas. There is a significant opportunity right now. Also, we are looking at commercial and residential sector, hopefully in the long run. So that propels the energy in the long term aspect. However, there are also other factors to be considered that we feel like it will also contribute to a developing market, such as the falling solar PV prices, because that is one of the major factors that can drive the market. And it would also continuously affect our costing as a project developer. The technology now, earlier, as we were looking at the presentation, there's been quite a big development in technology that can be useful for the developers. And all this we can reconcile to be a promising and still exciting market in the long term for the solar energy market in the Philippines. That's where we are at least. Thank you.
Thanks, May. You've mentioned solar panel prices decreasing, and I think over the last few years we've seen it go down significantly, especially over a 10-year perspective.
Yes.
But recently, I've seen panel prices shoot up like 40-50% from its previous 2019 lows, or I think 2019, 2020 lows.
Mhm.
Would you know the reason for that? And do you think this is a long-term issue?
Well, for us, maybe what we stand for is that there has been a great disruption of the pandemic. There has been an interplay of factors, such as, logistics has been very hard. The businesses have quite been low in terms of businesses. So practically, it would take effect on the pricing of this of solar panels now. But we are very optimistic that in the long run, as we come out from this pandemic, I mean globally, it will still give us an opportunity to actually drive the prices back to where we are at pre-pandemic. We're hoping that the industry would be active again. It's more of an economic activity, law of supply and demand. If there are a lot of demand, there would be a lot of supply, and there's enough supply, then it will drive the price down. However, given the pandemic in the last 2 years, there's been, like in our case, there's been no movement of any of our projects at all. So it might also be a price contributor, right? So still, we are optimistic that the prices would go down, even if it has risen in the last 2 years because of non-movement, perhaps for some of the areas in Asia Pacific region. But we're looking at, hopefully, and we're very optimistic that it would still bring down the prices, because it will help a lot the business developers in picking up from where we left off pre-pandemic.
Yeah, maybe we can actually hear from the source directly and from the
I
expert,
like that.
Lim. What is how long do you think this price volatility will stay, and what is the effect on the Philippine solar market?
I think what May has pointed out earlier, because of the pandemic, I think that has a great impact on the overall, not only on solar prices, but I think on a lot of things around the world now globally has also increased in price. But specific to solar panel itself, I would say it is related to some of the supply chain issues that has happened in China itself, and then I think it's getting resolved very soon. So I cannot say for sure when the prices will go back to the previous low, but what we see now is that definitely the pressure on the supply chain sides seems to be easing. So there might be some room for some price adjustment going forward to maybe 2022. But it's not only because of the supply chain. I think the freight cost itself is also a very major factor that's affected a lot of customers and project developers all over the world, because the freight price now, and I think is the containers that are shipping out can go anything from 7,000 to 10,000 per container. So that is quite significant cost to all the developers. Yeah, thanks, James.
Okay, thank you very much. Maybe
Hi,
we
Sir
can.
James.
Yeah,
If it's okay, I would like to add
of
also,
course.
possibly, if we look into the PV market overview in the Philippines, we should also look also with the National Grid Corporation of the Philippines developing the interconnection of the inter-islands of the Philippines to strengthen the grid so that what we call the large-scale power plants could be developed in other areas to carry this capacity. It means, of course, if there are large scale developers to develop solar projects, then the market would increase. And we should also see the commercial side. It means from residential to commercial area to industrial, it means even though the grid is not capable to carry all the capacity that the projects to be injected. Uh, these commercial projects, rooftop projects, if you add it as one, it's also a huge market, especially the residential. If only the information and campaign or drive to all the Filipino peoples to establish this solar power on their houses and commercial areas.
Definitely.
Thank
Thank
you.
you, Sean. Um, and it would also be great to hear from Evan from an international point of view. I mean, you're based in Singapore. DNV is obviously located almost everywhere in the world. How's your take on the Philippine solar market?
Yeah, well, I think, James, we have to know what investors are looking at, and there's an incredible investment appetite for solar and renewable energy projects worldwide. Lim was earlier describing some of the challenges around supply chain, and I think May also alluded to some of the difficulties that we've seen on prices. And with a lot of silicon being produced in the Xinjiang region in China, that's putting a lot of discontinuities in the supply chain. And so in the short term, that's one of the reasons leading to some increased prices, as a lot of investors from European and North American countries are taking a very careful approach with silicon from that region in China. So that's one reason and one challenge on the pricing point of view. I think on the market, like I said, the investment appetite is really, really high. And some markets in Asia Pacific in the past that have been very good for renewable energy projects, thinking particularly like Japan and China and Vietnam. There's a little bit of uncertainty in some of those markets recently. And so we're seeing a lot of markets in Southeast Asia really picking up. And Philippines is certainly one of those where international investors are really eager to go in.
I definitely agree with that. I think Philippines is generally a very exciting market. We have one of the highest costs of electricity in the world. We have great solar radiance. So it's really just a matter of, what's the missing formula here to get really aggressive and push 300, 400 megawatts a year. I think it's just a matter of time until we get there. But it's great to see that there's so many parties already involved and ready, because I think it's going to be very exciting the next few years. In line with that, we just recently heard of the new cell format, the new 210 millimeter cell large format modules from Lim. How do you think this could drive the solar market forward? Maybe Lim, yeah, we can start with you.
Yeah, sure. Thanks, James. So I think for the PV solar module, ultimately what we are looking at is how we can get more power out from each panel that we install in the project. So by using a larger wafer size, we are able to achieve a higher power bin. So for example, like say a same size project of 10 megawatt. So when we use a higher power bin as compared to a lower power bin, then you can see that the total number of modules used will be less. And this essentially will translate to savings at the system level. So this definitely shows that when we use a higher power bin, then we can get more savings at the system level. So this is one of the way that we are trying to help to drive down the cost at the system level side. So with this lower cost, then of course I think when developers or investors do their ROI and the studies, so it makes more sense for them to invest in the project itself.
So overall, the idea here is to lessen, of course, because of higher power modules, we'll need less mounting systems, we'll need less cables. That would be the reason for the cost decrease. Is that right?
Yes, correct. Yeah, you're right, James.
And on a panel cost basis, because of these modules being more efficient, is there any change in cost on a per watt basis from the predecessor versus the more efficient panel?
I will not say there is significant difference in there because I mean, having been a PV module manufacturer for over 20 years, so we have been also optimizing our production methods and also our supply chain. So in terms of the cost control wise, definitely we are still trying our best to keep it at a manageable level, so that will not be too expensive, which ends up taking up all the cost savings that we can get from using high power modules instead.
Right. And these panels are bigger as well, right? They have a much bigger square footage. It's like almost 3 square meters, right?
It's about it's less than 3 square meters. The length is about the biggest will be about 2.38, and then the width is about 1.1. So it's still slightly less than 3 square meters.
Okay. Does anyone else want to add anything to the
Sure. I'd
Sure.
love to add something.
Great.
Because I think what you're alluding to, James, was around the cost in dollars per watt, and this is always something that is kind of very perplexing for me and some others in the industry. That cost, and Capex is obviously a very important factor that goes into your LCOE. And I think Lim presented some real solid factors that can help reduce the Capex through the module and some other factors. But we always, you wouldn't buy an apartment just based on dollars per square foot, right? Certainly it's one factor, but it wouldn't be your sole determining factor. You're not looking for the absolute cheapest one possible. You really need to look, when you're purchasing a module, we always tell clients you need to look very holistically. You need to look at the company, you need to look at the reputation, the warranty, what kind of third-party testing has been performed, and several other factors. So I think in terms of dollars per watt, you can't deny that's important, and even how the module can be used for and optimized for low O&M cost, since O&M is also a very important part that goes into your LCOE calculation. But in terms of like moving the solar market forward in the Philippines, I think was it you, James, or maybe it was May, was talking about the difficult regulatory environment in the Philippines. And certainly that's one area where I hope we see continued improvement in the regulatory environment. But when you look at new PV module products, bringing costs down, but in actually realizing these costs compared to just a paper LCOE calculation, that's just a financial model. You need to actually realize that when you own and operate the project. And so that, going along with costs of competing sources of generation like coal and gas, is very critical to our clients when they look at, well, what's going to be the economics of this project compared to new gas and coal-fired plants.
Right. So yeah, the levelized cost of electricity, of course, is the most important determining factor. Are there other parameters developers should consider when choosing modules, other than, of course, efficiency, how that translates into, less other parts, and how that, you've mentioned a couple.
Yeah, I mean, I can comment, but I also want to give some of my colleagues online chance to comment. I mean, we would always recommend third-party testing and production monitoring. So third-party testing is kind of a batch testing where for large utility scale projects, at least 40 megawatt, 100 megawatt, 100 plus megawatt, you can work with your EPC contractor or your manufacturer in order to sort of randomly select modules, send them to a third-party lab, get them tested. We also recommend things like having your bill of materials pre-certified. There's a number of independent labs that we work with in part of our projects. One of the most famous is called PVEL. They publish a module reliability scorecard, which you can download for free online from their website.
Okay.
And DNV is not affiliated with PVEL.
That's very insightful. Thank you very much. Sean, would you like to? Do you have anything to add to this discussion on the
Yeah,
key
thank you very much,
parameters?
James. Well, for the parameters developers will be looking for is as even told us as the price, the cost per watt capacity. Then second is the availability. Of course, we should consider the availability of panels. It means when you build a project, you know the lead time, how it will come to your area. Then third would be the for now, I would be sharing we go to a panel that can reach a 1500 volt DC stringing capability. Yeah. Because the purpose of which, as we know that the higher is the voltage capability of each panel, then you will result into a lower amperage. It means the losses, because we are speaking of the yield of the power plant itself. Uh, Going to into higher volt capacity is resulting to a lower amperage, then you will have lesser losses compared to lower voltage capacity. For now, I think the existing grounds for the for the stringies would be around 1000 volt DC. Then now we will move up to 1500 volt DC. Then secondly would be the efficiency. As we received 5 years ago, I think the efficiency of panels would be around 15 to 16%. And now, as Sir Lim explained to us, it's above 20%. And that's very good. It's very attractive to all developers having panel efficiency greater than 20%. Then it depends what would be the technology we'll be using. Example, we want to save on space, and areas in the cities where there's reflective areas, you can use bifacial panel technologies, or else you can still move to the conventional with higher efficiency of panels. Then degradation rate, of course, we should also look into it. The present degradation rate would be if after 25 years, the manufacturers had given their warranty that the panels would have 80% of its yield capacity starting from the when you purchase the panel. And hopefully on the near future with newer technologies to build these solar panels, possibly the 80% could be increased to 85. Then it results to another yield or the whole power plant. Then and thirdly would be what we call would be the commitment. Of course, when we choose key parameters for the choosing modules, we need to seek commitments from the module, what we call the module developers. It means that when they develop the module that you will buy from them, if we truly want to have a change from on this present time, we would want that our modules are made also from renewable energy sources. It means it was built using renewable energy also, so that the carbon footprint would be lesser as we move. Because why we are talking about the solar panels and its use, because we want to have a change now. We are looking into climate change and reducing the carbon footprint effects. That's what we are also looking. Then resilience, of course, the resilience of the modules. We know that inevitably climate change will come. Of course, we should prepare these modules to be resilient on the upcoming climate changes here in the Philippines and around the world. Also, some wind stress, some earthquake stress test, and its capability to withstand that one. Then, of course, number three would be the hopefully in the near future or within these present times, manufacturers could also consider having a what we call a having their panels being recyclable. It means they could also offer to us, the developers, that after some time they would also offer to retrieve all the panels after its useful life to be recycled again, so that it will be produced in a more efficient way. And of course, we know that we will not be giving tons and tons of hazardous waste in our areas. It should be
Right.
recycled. Yes. Then, of course, we are looking also, depending on the cost, is to have the panels nano coated. It means it's hydrophobic and dust resistant. It means it does not attract most of the dust. And during rainy seasons, what we consider is that the rain will not leave much watermarks on the panels, because we know that the dirtier the solar panels, the lesser yield it will result for the power plant. Now, of course, we will also look into some areas like for now, we will be developing what we call floating panels. I think other areas in the world have been developing these floating panels. Of course, we should also consider the ingress protection of the panel itself, and its what we call the boxes. At least you will have a rating not less than IP67 for that, to ensure that the protection of the panel and the safety of the operation is what we call handled. That I think that would be for my points, Sir James. If other Miss May and Evan would add some more.
It's very comprehensive. Thank you very much.
Thank you very much. Thank you very much.
Um, yeah, I mean, in terms of model quality standards, um, so of course there are several factors to it, but from a core point of view, what needs to be followed to ensure the best quality and reliability? I mean, for those that are choosing solar panels now, what do they really need to look at? For not big time developers, but let's say, businesses that want to adopt solar and they're now unsure of, what kind of solar panels would I get? Because there are different technologies. Obviously, there's polycrystalline, polyperk, monoperk. There's high wattage, low wattage, and for a lot of people this is very overwhelming. So what should be the core things that anyone should look at when choosing solar modules? What will determine, or what is a good hint towards quality and reliability?
Do you mind if I take that one?
Go ahead, please.
All right, thanks, James. So I think one thing that's really important to distinguish to your question, James, is around small developers and maybe factory owners versus large international developers. And to be honest, DNV, usually we deal with large international developers and investors more often than not. But I think it's also beneficial to frame the context of the question occasionally in the small side. And so obviously the bank accounts of large developers are going to be much more, and they can have many more requirements to put on their module suppliers. But taking a look at really what is the minimum, the really minimum is that the module must be type tested. So it must be type tested by a international third-party laboratory. There's a few of those out there to common standards. UL 1703 is one of them. IEC 61215 is another one, and 61730. I think, in my opinion, this is the absolute minimum. But we should also recognize what type testing is. It's type testing just a certain bill of materials independently in a laboratory. It doesn't necessarily mean that the modules you buy are necessarily the same as that. So that's what is typically recommended as a minimum for small procurers of modules. But I think maybe Lim would also have something he'd like to add. What would you recommend, Lim?
Yeah, hi Evan. Generally, I think like the standards that you have mentioned earlier. So this is really, the I would say the bare minimum, which is applicable for almost, I would say, 100% of the current module manufacturers. So on top of that will be like what you have said about some third party testing or some kind of enhanced testing beyond the IEC standards. So like example for like the damp heat test, the standard is, let's say, 1,000 hours, but some clients go for 2,000 hours or even 3,000 hours. Then at the same time, the other thermocycling test also, there's also higher standards. Even in terms of the PID test, there's also different higher standards. Let's say 3 times, 2 times IEC standard. And I think one interesting point that we have been encountering is also on the fire class itself. So there's a lot of emphasis on safety. So it's like when we look at the conventional module, the backsheet modules, those are generally all fire class C. So for the class modules, some of them can go to fire class A. So it really depends on the application and the projects that the developers are developing and installing. So overall, I wouldn't say that, I cannot say that there is a golden standard that everyone must follow and every module must follow this golden standard, because it can also differ from different countries, different project site. So as an example, if let's say we use on the floating projects, so of course, to be able to manage or for the module to withstand 30 years in this kind of floating high temperature, high humidity environment. So naturally, the bomb selection or some of the parameters, we have to be maybe a bit extra careful on that. But if you're looking at just a normal rooftop application, which is a very I would say common kind of ambient temperature with a standard humidity, then maybe we don't really need that kind of very very high standard bomb to go into this kind of modules. Because if everything is going to the higher standard, then I mean the cost will also be the highest cost. So it has to be a balance between what is the application and whether and also the balance between the power of the module and the cost and the technologies and all the different materials that we use.
Right. Lim, I have a follow-up question to basically technically unrelated, but I was very curious about this. Generally, the warranties of modules, they're typically after, basically there's a performance guarantee for 25 years, right? Is that still the standard today, 25 years?
Yes, that is still the industry standard today. So for backsheet module, it's still 25 years. And then for the glass module, it's 30 years of performance warranty.
Okay. And from a panel manufacturer point of view, is there any recycling kind of structure or what sort of is happening currently in the industry? I know there are some companies trying to bring that in, but what happens after 25 years, 30 years with the panels? Because technically they still work at a 80% performance capacity. But are panel manufacturers actively trying to look into this as well?
Yeah, thanks, James. I think module recycling has been a long time topic. So it has been everywhere. So of course, if you look at Europe, it's definitely much well established. They have the PV cycle that is handling module recycling. So as long as you are part of the member, so when you have modules that is defective or expired modules that you want to dispose of, you can contact the PV cycle where they can come and take the modules away and do the recycling. But outside of Europe, for different countries, let's say in the ASEAN region, we still don't really see strong government regulation that impose on the developers or rather on the projects that after 25 years, there are certain guidelines that you have to follow, what you have to do to the modules, to the structures and everything. So I think recycling itself is a big topic, which definitely everyone is seriously studying into it, and also coupled together with the local authorities, regulations and effort to try to look at what will happen after 25 years. So if you talk about from technology standpoint, then of course, after 25 years, definitely there will be some new technologies that's already in the market. So naturally, it might at that time it might really make sense to change to a new technology because of
Right.
even better power generation or even lower cost. So it's a bit hard. So definitely, I would think that recycling is a big topic that going forward.
Right. Thank you for that. May I have a question on your project? So you've mentioned previously that you already have a 50 megawatt project that's pretty much operational, or that is operational. What did you look for when choosing your modules?
Well, we have to take the perspective that we were actually vying for fit at that time, so the costs were still high. But most of it, we were actually looking at the warranties, the guarantee. Remember, we were like, when we did the race for fit, we were one of the hundreds of companies who would want to make it to fit. So
Yeah.
anything that was available at that time, the lead time was very important because we had a race to do, right? And then also the guarantee, because during that time when we were building the plant, there's been no plant in the Philippines who have actually reached 25 years and could practically tell us as a testimony that,
Yeah.
hey, this is what happens after 25 years, especially with the panels. So we just had to make sure that the guarantee was in place. The warranty was in place, of course, because it was one of the first projects that we did. So practically, we were a newbie in the industry. We didn't have much experience, and that the warranty would be our control system at the same time, our safety in the next 25 years. And of course, the cost was a very considerable factor in checking on the EPC proposals, because knowing that we were vying for fit, but there was also the uncertainty that we might not make it. And hey, we didn't actually make it at the end. Now,
Yeah.
so recovery is very important in terms of investment. So those are the most important part. And I think from the operations side, they were very particular with, the module efficiency, things like those. I cannot just expound on much because I'm not the technical person. I'm from the business development side, but much of what Sian or Sean has discussed comprehensively earlier, much of it I have heard in the discussion with our operations team, including the maximum power temperature coefficient they were talking about when we were preparing for the project. But from the business development side, we were into warranty, guarantee, the price, the manufacturer, the availability, and most especially the lead time was very important for us at that time.
The macros. Yeah, that's very important to hear and very good to hear. I'm curious though, what do you remember the panel capacity you used at the site? Was it
From what I know, we just did the 250.
250 watts?
Yeah.
I think those were sort of one of
Because
the
that was the first batch of solar panels we that were available at that time.
right. Yeah, that's actually, so comparing with today's 600 plus watt
Yes,
panels.
this is practically a great development,
Yeah,
and the cost as well. We were still at the higher end of the costing at that time. Can you imagine? At that time, one megawatt was 2 million USD, but now they say some of our suppliers would say that we can now develop a utility scale by 800,000 USD. So that's kind of a big gap or disparity in terms of price. So there's much recovery from our end when we were.
apparently the cost of solar is now 80% less than what it was 10 years ago.
Yes.
So that's a very significant,
There's a significant disparity in terms of price and cost.
for sure. Okay, and so I guess lastly on maybe we'll do one more question and then we'll have some Q&A. we've been talking about LCOE earlier, and so I guess really the question here is how the latest PV technologies is impacting the plant LCOE. We spoke a bit about the 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 efficiency of solar panels being increased, and that has an impact on, I guess, the balance of system. And apart from that, or if we can go a bit more detailed into the LCOE, or for those that maybe don't know, what is the levelized cost of electricity? Who would like to give a quick explanation on the LCOE and the and discuss maybe the impact on
Okay, I can try. LCOE is very simple on its surface, but is very complicated if you want a very precise definition. So I'm sure Google can probably provide a more precise definition than I can, but it's basically the cost per kilowatt hour or the levelized cost of energy. And so the objective is really to take all of your costs and divide it by all of your inputs over your outputs. So you want to be able to compare different technologies against each other. So you'll find online a lot of graphs where you can see the levelized cost of energy of solar, wind, gas, coal, and you'll see how over time solar and wind is coming down almost, say, exponentially. And so what you'll see is that we're coming very close to a point in many markets where the levelized cost of energy is approaching traditional forms of energy generation. So in many markets for renewable energy, it's still a little bit higher if you take it on a subsidized or unsubsidized basis. So basically you want to remove all the subsidies and try to do a fair comparison of different technologies. But of course, subsidies can very much distort this cost of energy. So in the old days when you'd have FIT, for example, right, you can get a very distorted picture, or if you're having subsidies towards coal or natural gas, then you're going to get a distortion. So many comparisons try to remove these distortions. But I think, in terms of what has been provided on the PV module side, some of the things that go into that calculation are anything that affects Capex, OpEx. And so Capex is going to be like BOS, is going to be module cost, it's going to be, say, land cost, or if there's any cost allocated for rooftop space. So if you have something like a high efficiency product that can utilize your space more efficiently, you're going to be reducing your Capex cost of your space. And I think, one of the panelists was saying something about floating solar. And so floating solar, in some cases, you may think of it as free space, but I would say more often than not, the owner of that space wants to monetize it. So that space also has a cost. And so Philippines is a very key market for floating solar. And we see a lot of technologies on floating solar being developed very fast, and many very large lake spaces in the Philippines having very big potential for large utility scale floating solar projects. So I hope that gave a little bit of an overview on LCOE and some of the important factors that go into it.
Thanks, Evan. On LCOE, though, to clarify, because you mentioned it's basically the total cost over basically the life of the project divided by the total estimated energy output,
Mm-hmm.
and you basically just get a rate per kilowatt hour that gives you a more, I guess, accurate cost per kilowatt hour, because there will be, I guess, more expenses towards the end of the year or towards the mid of the year, where there are certain replacement costs and higher maintenance costs, lower output. And I guess that's the whole point of the LCOE, is to sort of understand what's really the actual true cost per kilowatt hour on an average basis. However,
Yes, that's right.
there's obviously time value of money makes a big difference as well. Is that factored in the LCOE?
Absolutely. So the discount rate is part of the LCOE calculation. So the cost of capital is one factor that goes into it.
Great. Okay. Good to know.
Thank you very much, James. If I can add,
Of course, please.
it actually, in my point of view, also is that speaking of LCOE, maybe during last 10 years, 5 years, using a 25 hectares land could give you around 25 hectares. 25 hectares of land you could give you a 25 megawatt peak power of solar power plant. But nowadays, I think using a 25 hectares land, you can build around 27 or 28 megawatt peak power plant. It means what we call, of course, as Sir Evan said, that you have a lesser cost for the space, or it's either you have a lesser use of the space or for the lease cost or the cost of the land, or you could have increased your capacity, of course, increasing the denominator, because LCO is cost over energy. Then increasing the denominator, numerator denominator, it means you reduce your LCOE. It's like that.
Okay.
And of course, Sir Lim also told if
That makes a lot of
later
sense.
on the cost of solar panels, PV modules will be dropping down, then I think everyone knows that in a solar power project, you are playing around 40% of the project would be the solar panel cost. I think, of course, dropping that down into significant figures would also decrease your LCO. That's my
That
addition.
makes a lot of sense. Thank you very much, Sean. Okay. Anyone else who still wants to add to that question? If not, then I think we can move on to the Q&A.
Yes, actually, we haven't got any questions in the Q&A box. Actually, the
Okay.
audience might have posted on the chat session, which is not easy to track actually. So, proceeding forward, I would like to announce our winners of the contest. That is Mr. John Carlo Garega from Advanced Energy Technologies, and also Mr. Ron Christian C. Great from Team Energy. So these are the two participants who have won the contest and will be getting a hamper from Tina Sola. Also, with this, I would like to thank all the panelists who joined us today and did this great discussion. Special thanks to James for superbly managing the session. It's not an easy task, but you made it look effortless. So, thank you so much, everyone, for extending your time and support for the event. We promise you to come back with more exciting topics very soon. Now, the floor is open for networking. Thank you, everyone.
Thank you, Priyanshi. Thank you, everyone.
Thank you very
Thank you,
much.
everyone.
Thank you, everyone. Thank you.
Bye.
Thank you all. Nice meeting you.
Nice
Nice
meeting
meeting you
you.
all,
Likewise.
James,
Thank you.
Evans,
Thank
and
you. Take
Thank
care.
you.
Miss May,
Yes, bye.
Bye bye.
Ma'am Priyanshi.